Hi, grade 11, this is Mustafa here. I sent you the grade 11 math exam review paper. So it consists of 4 pages and approximately 18 questions. So what we're going to do today is we're going to solve this paper question by question, and I will try to explain the solutions for each of these questions that we have. So let us get straight into this review paper. So question 1 says, find the amplitude, the period, the range, and the frequency of the functions. So if we have the first function is f of x equals negative 2 sine 4x. So if we say number 1, we have f of x which is equal to negative 2 sine 4x. So if we want to find the amplitude is the absolute value of the number in the front, which is negative 2. So this is 1a. The amplitude we have here was the amplitude. Amplitude is equal to absolute value of negative 2, which is equal to 2. So just remember, even if you have a positive or negative number in front of the sine and cos, it's always the positive answer because we have to take that absolute value. Just say if it was 3, it would be 3. Next we need to find the period. The period of this function will be, you can write it in terms of degrees, or you can write it in terms of radians, because it depends on the two measures what's given in the multiple choice. So let us write the period in degrees and in radians. So in degrees it will be 360 degrees divided by the coefficient of x. Anything after the sine argument, you need to look at the coefficient of x, which is 4. So what we get is 360 degrees divided by 4. For sine and cos, that's how we find the period, and for tan we have to say 180 degrees divided by the coefficient of x, which is b. Yes, so what we get here is 90 degrees, and we know 90 degrees is also pi by 2. So 4, to find the period, we can also say, to find the period, we can also say 2 pi divided by 4, which will give us 2 pi divided by 4 will give us pi by 2. And we know pi is usually, pi is 180 degrees over radians. Right, so that gives us the period. If we want to find the range, remember the amplitude is 2, so going at a height of 2 and 2 down, so the range will be y values. So I usually write y is an element. The starting value is negative 2, and the starting value is negative 2, and the ending value is 2. So the starting value is negative 2 and the ending value is 2. In other words, negative 2 is the minimum and the maximum is 2. Also on the same question we have frequency. What is the frequency? Frequency is basically 1 over the period. So let us just write this down here. Frequency is equal to 1 over the period. So make sure frequency is always in radians measure. So if we say 1 over period, we should get 1 divided by pi over 2. So if you use your calculator and say 1 divided by pi over 2, you should get 2 over pi, or you can also get your answer in decimal cases. So what we have is 2 over pi. 2 over pi. So let's do this thing. So you got 2 over pi. That's my, because if you say 1 divided by the period, you have to basically go and flip this fraction. It will become 2 over pi. I hope you're understanding, guys. So next one, what we have is a different function, which is 3 cos 2x. So we have f of x, which is equal to 3 cos 2x. The amplitude, again, they're asking us the same questions, right? But this is a different example. Amplitude is a number in front, so we have 3. Next thing is the period. The period we'll write on the side here. Okay, so what's the period? Period is 360 degrees divided by 2. So period is 360 degrees divided by 2, which is going to give us 180 degrees. Or the period in radians is equal to 2 pi divided by 2, because we want it in radians. And 2 pi divided by 2 will give us a pi. And from the period, we can also work out the frequency. So let's just work out frequency, which is equal to 1 over the period. So if you say 1 over period, period is pi, so 1 divided by pi will be my frequency. Next, obviously we work out the frequency. We can work out the amplitude, the period, the range. We need the range. So what is the range? Range is basically y is an element. What's the starting value? Because we're going 3 cos 2x, there's no transformations in this function. So we go 3 up or 3 down. So minimum value is -3 and the maximum value is 3. So we have the range. Moving on to question 2, it says list all the zeros and the range of the function y equals 2 sine 3x. So question 2 says list all the zeros on the range of the function y equals 2 sine 3x. So if you look at this function closely, what you see there is when they talk about listing the zeros basically means all the x-intercepts. So I can see all the x-intercepts is all the x-intercepts are x-intercepts are basically zeros. So let's just write down zeros instead. So what are the zeros? Zeros equals x, which is equal to, we can write it in a set notation. I hope you guys have the page in front of you and are looking at the graph. So we have the zeros and the graph is given in terms of pi. So I can see we have 5 x-intercepts. So we have -2 pi over 3. We also have -pi over 3. We also have the 0, which is the x-intercept. It's the graph which cuts the x-axis of zeros. We also have pi over 3, and finally we have 2 pi over 3. Right, so these are all the 5, make sure you close it in curly brackets. So we have 5 zeros. What's the range of that function? We can see the range, we can just figure it out from here. So what's the range? Because there's no transformations at the end of the graph. See, there's no transformations at the end. So we can just say range is y is an element. Or you have to, the best way to find a range is to look at the graph if the graph is given. So we can say y is an element from -2 to 2. Right? And that's the graph of the function. Looking at the graph, we can analyze this function, find the zeros and the range. Moving on to question 3. Question 3 says you need to sketch a graph, which is y equals cos, we have x plus pi by 3, x plus pi by 3, where x is from -180 to 120 degrees. So what we see here is we have a pi by 3 here, so convert that into radians, right? So we have pi by 3, which is radians, so we can convert it into degrees. And we convert it into degrees, see what we get. We have cos of x plus 60 degrees, and we have the starting and then ending values. Of course, you can do this on the calculator using the mode. You need to press mode, and then you press 7, the table method, and type this function as is. Cos alpha x plus 60 degrees, close the bracket. Make sure your calculator is also on degree mode because we are working with degrees. And if you press equals, start end, try it again, mode, cos alpha x plus 60 degrees, close the bracket, starting at negative 180, ending at 180 degrees. How do we know what to step? Try to use steps of 60 degrees because this graph was transformed 60 degrees to the left, the plus 60 degrees to the left. So I would use steps of 60 degrees. And I end up with 7 points. Yes, so we end up with 7 points. So basically these are the types of points we are getting. Just a rough sketch. Right, and because we're ending up 7 points, these are 60 degree intervals, so that should give me negative 180 on this side, 1, 2, 3, and 180 degrees here. And I'm getting some nice values. When it's negative 180, it is negative 0.5. So we have 0.5 and negative 1 here. We have 0.5 and 1 here. So when it's negative 180, it is negative 0.5. When it is negative 120, it is 0.5. When it is negative 120, which is here, it is 0.5. When it is negative 60, it is 1. When it is 0, it is 0.5. When it is 60, it is negative 0.5. 60 degrees is negative 0.5. And 120 is giving us negative 1. 120 is giving us negative 1 in the calculator. And 180 gives us negative 0.5. So what we can join is we can join these 7 dots and get a nice graph. So let's try to join these dots. Right, so that's my graph of cos x plus 60 degrees, where the value is starting from negative 180 and ending at 180. What's nice to note here is to find the x-intercepts. To find the x-intercept, first plus symmetrical x-intercept. Should move this little towards this side. Yeah, first space dot. If you try to substitute, remember this is 120, negative 120. If I want to find the x-intercepts I can say is try to take a midpoint between these two. You will see if you are sketching the graph, draw to scale, you will find that you get in a value in between these two values, negative 180 and negative 180. So you should get the x-intercept as negative 150, or the next intercept you get a value between 0 and 60, right? Which is the 70 degrees. Now, if we put negative 150 in the calculator, so cos, replace the x with negative 150, substitute basically, you should get cos of negative 150 plus 60 degrees. I see that I'm getting 0. And if I substitute 30 degrees in the place of x, I see that I'm getting 0 as well. So I hope you understand, guys. Just apologies that couldn't do it on the writing pad. This is the hand. Okay, question number 4. Find the minimum and maximum value of the functions. Please make sure that you guys have the page in front of you. Right? So question number 4, we want to find the minimum and maximum value of the function. Right? So number 4. So we have f of x, right? Which is equal to negative 2 cos 3x, right, minus 4. So what we see here is that the original graph was negative cos 3x, right, and this graph was shifted 4 units down. So what's the minimum value? min value and what's the max value. Right, so what we see is the minimum value is -2 because that's going to be a wave graph, -2, and the graph is being translated 4 units down. So 4 units down below is -4. So we get the answer of we get an answer which is -6. That's the minimum value of this function. And the maximum value is 2 minus 4. Why minus 4? Because this graph is transformed 4 units down. So we get -2 as an answer. I hope you understand, guys. So that's the minimum and maximum value of the function. If we want to know what's the range will be from -6 to -2. So just in case we ask you for the range will be y is an element from -6 to -2. Remember minimum value first and the maximum value. Similarly, we want to find this was 4a. Similarly, we want to go and find the minimum and maximum value of the function, which is 3 sine 4x plus 3. So g of x, we have the function 3 sine 4x. 3 sine 4x plus 3. So what's the minimum value here and what's the maximum value here? So the minimum value here will be, obviously the graph is being transformed 3 units upwards. So minimum value we know from this 3 will be -3, and because we are transforming 3 units upwards it will be +3, which is 0. Minimum value is 0. And the maximum value is 3 because that's the height up, because the amplitude is 3, so you're going 3 up and 3 down. Because it's 3 down is still 3 and 3 up is because of the amplitude, so you start with 3 and then we add 3. Why we add the 3 at the end, why we add the 3 at the end here as well, is because this graph was translated 3 units upwards. So we have the maximum value which is 6. Right, and if you want to write the range, you can write it like this as well, not always in equal ratio. We can also use an inequality notation for the range, which you can also write as we're starting at 0, right, is greater than equal to y or less than equal to 6. You can also write it like this, or if you are comfortable writing it like this, with 0 and 6, that's fine as well. I hope you understand it, guys. Now let us move on to the next function, which is simplifying log functions. Number 5. Yes, write the following logarithm in the extended form. So we have log 5/8. We have log a squared b cubed divided by c to the power 4. Right, we have to see what's happening. Now we know when log is a log of a fraction, when there is products on the numerator, all the numerator becomes plus, and when there's something in the denominator it becomes a minus. So rule number 1, we said this is log, try to expound. This is a squared plus log b cubed, minus, because that's in the denominator, so it will be log c to the power 4. And then we have the power rule for log, where the powers goes to the front and becomes coefficient. So we have 2 log a plus 3 log b, and then we have the 4 coming to the front, right? Each of these ones goes to the front because that's the power rule for log. Minus 4 log c, and that's the answer. No dot there. We have 4 log. Here's the squash. 4 log c. Right, and that's the answer. 2 log a plus 3 log b minus 4 log c. Second example, we have number 5b, which is log base 3 AB over CD. Now, because we have A and B on the numerator, it will be plus, and because we have C and D in the denominator, it will be minus and minus. So we end up with 4 terms. So we have log base 3A, log A base B, plus log B base 3 minus log C base 3 minus log D base 3. Why minus and minus? Because that's in the denominator. Part C, we have lim 11 over 4 to the power p. We know p goes to the front first, and then we need to extend. So we have p lim 11 over 4. Now because we have a division, it will become subtraction. So we will have p lim 11 minus lim 4. Now because we want to expand this, why negative? Because it's in the denominator. Because we want to expand this, we need to distribute into the 2 terms that we have here. So we have p lim 11 minus p lim basically means natural log, right? And natural log, what is natural log? Is log x base e. Example, what's lim x? Remember, lim x is equal to log x base e. So remember this, right? Now, after we have expanded the single log into the expanded form, now what if we say take the expanded form and bring it down into a single log? So that's what we're going to do next. So number 6, question number 6. We have 6a, which is 4 log 3 minus 3 log 2. So the first thing that we do is we take all these coefficients and bring it to the powers. So it's going to go to the power, bring it to the power. So we have log 3 to the power 4 minus log 2 cubed. We know 3 to the power 4 is log 81 minus 2 to the power 3 is log 8. And now we just simplifying this, that will just become log 81 over 8. That basically is to a single log. So when you brought this down to a single log, remember log on its own is to base 10, so still base of 10, writing base 10, right? Looking at 6b, yes, 6b we have log 3 plus log 5 plus log 6, and because we have everything as product, everything as a plus, writing it as a single log will just become product. So log 3 times 5 times 6. So what we have is 3 times 5 is 15 times 6 is 90. So what we have is log 90. Looking at the next question, part C, number 6c, we have 4 log a base 6, 4 log a base 6 minus 7 log b base 6. So the first thing what we'll do is we'll bring all the coefficients to the powers, right? And we'll say this is log a4, a to the power 4 base 6 minus log b to the power 7 base 6. So because we have subtraction of logs, we can divide. Log a to the power 4 divided by, why divided? Because it's negative, and b to the power 7, and we have base 6, and that's my final answer. But guys, we'll just take a 2-minute break and then come back for from example number 7, 8, 9, and so on. Right, so now we're going to solve example number 7, find the value of number 7a. So we'll find the value of Right, so you can find the value of log 25 base 4. Log 25 base 4. Log 25 base 4. So obviously we need to use a calculator there because you can't really get the exact answer. And remember, when you're using the calculator, try to round off to the nearest thousand. So log 25 base 4. When I'm typing log 25 base 4, I'm getting an answer of 2.322. So 2.322. Remember, when you type it, you have to put these parentheses there. Looking at the next question, B. We have log e squared base e. You can type this on the calculator as is, or if you know the rules, you can bring the 2 to the front, right? So we have 2 log e base e. We know log e base a or log e base e cancels out, becomes 1, so my answer is 2. And the last problem, which is C, is log 64 base 2. You can type it on the calculator, log 64 base 2, but because I know that 64 can be written in terms of base 2 as 2 to the power 6, right? I can say now, bring the 6 to the front and do the same thing. So 6 log 2 base 2, and that will give me an answer of 6 because log 2 base 2 cancels out, it becomes 1. Right? We can just have the on the calculator as is like this. Moving on to the next question, we want to solve some exponential equation, then the log equation. So now in 8a, just try to correct the worksheet. This a should be not a to the power r, a to the power x equals b. So we want to solve for x. If you want to solve for x, you need to use log. So x equals log b base a. Yes, and that's my answer, log b base a, because you are trying to solve for the exponent, where a is unknown and b is unknown. Part b, we want to solve the next problem, which is 2 to the power x equals 7. So if you apply the rule directly from what we have done here, we just say x equals log 7 base 2. Now if I use my calculator, log 7 base 2, let me try it out, log 7 base 2, log 7 base 2 is going to give me 2.807. X equals 2.807. The third problem, which is C, we have e to the power 2x plus 1, which is equal to 10. That's my question. Now to solve this, we will use a similar thing like what we have done here. So we say 2x plus 1 is equal to log 10 base e. But we know log 10 base e is basically ln 10. Because log x base e is ln x. So log 10 base e is ln 10. Now remember how we're going to solve this equation. We're going to minus the 1 because we have to take that over and then divide it by 2. So x equals ln 10 minus 1 and then divided by 2. The 2 is on here, so let's see. So we're basically dividing it by 2. Right? That's a 2. Ln 10 minus 1 divided by 2. If I use my calculator and work it out, I have ln 10 minus 1 divided by 2. I get 0.651. 0.651. 0.651. And then the last question, make sure you round off to 3 decimal places or to the nearest thousand. The last one is 4 to the power 5x. D 4 to the power 5x. We have 4 to the power 5x is equal to 7 to the power 3x. 7 to the power 3x. Please correct that and put a minus 1 there. Now, because we have different bases on both sides, we'll introduce log. So we say log 4 to the power 5x equals log 7 to the power 3x minus 1. We will bring the powers to the front right? Power rule of log 4 3x minus 1 log 7. Now, because we have two terms on this side, we need to open up the brackets, right? Yeah, so we have 3x times log 7, so 3x log 7. That's 3x log 7 minus, that's 1 times log 7, which is just log 7. And this is 5x log 7. Now, in order to solve this problem, we need to group all the x's on one side and the numbers on this side. The number is negative log 7 and 3x log 7. There should be log 7 there. Now, we bring this log 7 over, so we've got 5x log 7 minus 3x log 7. Sorry, this is 5x log 4, should be log 4. Correction, yeah, because that was base, that was 4 to the power, so log 4. 5x log 4 minus 3x log 7 is equal to negative log 7. Now, we take out x as a common factor because we're solving for x, so we have 5 log 4 minus 3 log 7 equals negative log 7. Now what we do is we need to divide the negative log 7 by this coefficient. Right, so this is the imaginary coefficient that we need to divide by. So x equals negative log 7. Negative log 7. See? So you can say x equals negative log 7 divided by, what was it? 5 log 4 minus 3 log 7. 5 log 4 minus 3 log 7. And now we can work this out on the calculator with the answer. We add it to log 7. You got 5 log 4. Make sure to put parentheses when you are working it out on the calculator. Minus 3 log 7. Right, so I'm getting an answer of negative 1.779. Negative 1.779. I hope you understand this. Don't forget to leave comments below. Question number 9. Let us solve question number 9. We have, yes, so we want to solve the log equations 9a. Right, so we have log base 5, we have 3x, very simple, right, which is equal to log base 5, 18 plus 6x, right? Now, in order to solve this problem, very simple, because we have same bases, we can cancel them out. So log 5 and log 5 cancel out, and you can see a very simple equation that we are left with to solve, which is 3x equals 18 plus 6x. We can take the 6x over, or bring the 3x over, anything, right? So let's bring the 3x over, you get 3x, and taking the 18 over, you get negative 18. Now if we divide both sides by 3, right, we get x is equal to negative 6, and that's my answer. We'll go on the next. And now solving the next problem, which is part B. Just going back to the previous one. I hope you understand. We just have a look at what we have done. Because we have same bases, we drop the base, right? And we solve the basic log equation. And now looking at something similar, we have then 2x plus 3 equals ln negative 2x plus 7. Now, because we have same bases here as well, why do we have same bases here? Is because ln natural log ln is to base e, log x base e, right? So we can drop the ln on this side, and on the side over 2x plus 3 is equal to negative 2x plus 7. We can bring the 2x over and the 3 over, right? So we have 4x, and 7 minus 3 is 4, so x is now equal to 1. I hope you understand, guys. Right, and then part C, something similar. Log base 8, right? And we have x squared minus 15, x squared minus 15, right? Is equal to log, again we got log base 8, so we can drop the same basis for logs. Alright, so equals 4x. Now what we can do is we can simplify by dropping the log base 8. See, right, so remember we need to drop the log base 8 and drop the log base 8. And now what we have a simple equation to solve where we need to bring the 4x over, so we got x squared minus 4x minus 15 is equal to 0. In other words, we have a quadratic to solve, right? We have an equation which is quadratic. In order to solve this problem, we open up two brackets, right? Which is equal to 0. We put an x here because x times x will give me x squared, right? And now the product of two numbers should give me negative 15. And so which two numbers can I choose here? Let's see. Minus 4x minus 15 is equal to 0. So 5 and 3. 5 times 3. Was it negative 15? Oh, it wasn't negative 15. That's the reason why it's not working out. It should be negative 45. So negative 45. That's negative 45. Just a correction in your question. Should be negative 45. That's the reason I'm checking why it's not working out. It should be negative 45. So x squared minus 4x minus 45. So now we can see 9 times 5 is 45. So put the 9 here and the 5 there. Right? 9 times 5 is 45. But negative 9 times positive 5 will give me negative 45. And negative 9 plus 5 will give me the negative 4. So we need to check the sum and the product. So x equals negative 5 or x equals 9. Now we need to check which one works, which one does not work. We can see x equals to 9 works, but x equals negative 5 does not work. So 4 times negative 5 does not work, so we just say reject, right? Or we can just say extraneous, right? So this is an irrelevant answer. That is irrelevant because if I substitute negative 5 inside here, you can see 4 times negative 5 log of negative number, which does not work. Right? I hope you understand, guys. So we only have one solution, which is x equals 9. You can also find a solution on the calculator where you can use mode equation 5 and then go to the quadratic equation, which is 3, mode 5 3. Substitute the value of a, which is 1, press equals, minus 4, press equals, and the value of c, which is negative 45, press equals. I am getting an answer of x equals 9, and I am getting an answer of x equals negative 5. So if you bring this over, you get the factors plus 5. With that over, you get the factor, which is next. Right. So we have learned that in Polynomial functions, factorization. Now moving on to question 10, we are to use estimation to solve the value of x. In other words, we need to look at the graph and find the points of intersection. Right? So the estimation of this. So in number 10, we have the function 3 times 2 to the power x plus 2, 2 to the power x plus 2, which is equals to, there's a minus 1 here, minus 1, which is equal to 3 minus x. Now, they're not going to tell you which one is f and which one is g. You've got to go and figure it out. From the graph given, we know the curve is an exponential function and the straight line is the second function, which is g. So basically what you're saying is f of x equals g of x. In other words, we are finding the points of intersection points. So I can see both the points are intersecting exactly at approximately negative 1.2. So x equals negative 1.2. At x equals negative 1.2, I want to find the value of f of negative 1.2. In other words, I'm substituting negative 1.2 on the left function. So I'm getting 3 times 2 to the power negative 1.2 plus 2 minus 1. What answer do I get there? So I'm trying to check that answer. Let's see. Mode 1 computational 3 times 2 to the power negative 1.2 plus 2 and then minus 1. I get an answer of 4.22. Right, so I'm getting an answer which is 4.22. Right? 4.22. Right, 4.2233038. And now if I substitute the next value of negative 1.2 in there, it's quite simple. Into the g of x function, negative 1.2. Then I'm substituting it inside there, negative 1.2, 3 negative 1.2. I'm getting an answer of 4.2. So I can see that this answer and the answer above is approximately the same. So you can say x is approximately equal to negative 1.2 because this answer, these two answers are the same, so almost the same. It's approximately the same. So I have an approximate solution. That's the reason why the question asks to estimate the value of x so that this equation is true, and which is from the graph that you need to form, right? So from this graph. Next types of equations, the next topic that we are working with now is arithmetic and geometric and quadratic sequence, and you have to see required to write the recursive and explicit formula for the sequence. I hope you're understanding, guys, like this here. Question number 11 says, name the type of sequence, arithmetic, geometric, quadratic. If so, write a recursive and explicit formula for the sequence. Let's just have a look at the first one, number 11a. 11a, we have 3. We have 3, 9, 27, 81, and so on. What we can see is that we are multiplying by 3 each time, so you need to say if the sequence is geometric, because whenever you multiply and divide, the sequence will be geometric, so we will be geometric. Why it is geometric? Because the common ratio, right? Common ratio is equal to common ratio because the common ratio is equal to 3. And so what's the recursive formula for the recursive formula for the geometric? an is equal to r times an minus 1 if a1 is equal to. So what's an? An is equal to what's r? 3. An minus 1, right? If a1 is equal to 3, because the starting value is 3. You write it like this, or you can also write it as in step function notation. An, which is equal to, what's a1? A1 is 3 if n is equal to 1, and 3 times an minus 1 if n is greater than 1. How do you understand, guys? That's the recursive. What's the explicit formula? Very simple. The advantage of using the explicit formula is that we can find any term first. The disadvantage of using the recursive formula is that if you want to find a10, you need a9, a8, and so on. You need all the terms before. In other words, the recursive formula is kind of sequential, and the explicit formula is, you can just find it at any point. So what's the explicit formula? Is given by an is equal to a1 r to the power n minus 1. So what's a1? 3. R is also 3 to the power n minus 1. We know when we add powers to the same base, you can just add the powers. So remember, this is to the power 1. 1 minus 1 cancel out, so you can also write the answer as 3 to the power n. Okay? I hope you understand, guys. Looking at part B, 4, 8, 12, 16. Part B is just 4, 8, 12, 16, and so on. We can see we are adding 4 each time, so it is an arithmetic sequence. Whenever you add and subtract, it is arithmetic. You need to say why it is arithmetic, because why it is arithmetic? Because we are adding 4 each time. In other words, common difference, not common ratio, common difference. So common difference is equal to 4. So what's the recursive for arithmetic? Recursive for arithmetic is an is equal to an minus 1 plus a if a1 equals, so an is an minus 1 plus 4 if a1 is equal to 4. You can write it like this, or is simplification. And what's the explicit? The explicit is basically an is equal to a1 plus n minus 1 times d, right? And what's a1? A1 is 4 plus n minus 1 times 4. Now you take the 4 and distribute into these two terms here and there. So you get 4 plus 4n minus 4, right? And then plus 4 minus 4 cancel out, so you just get 4 times n. So you're basically counting in 4s. 4, 8, 12, 16. If I substitute 5 divided by 6, we are getting 20, and which is the next term. So the answer is correct. Next part, number 11C. We have 1, 0.5, 0.25, 0.125, and so on. If we convert this into a fraction, then we will be able to see the answer. That's just 1. This is 1, that's half, that's quarter, that's 1 over 8, and so on. So what you can see is that this pattern is geometric because we multiply it by half each time, or we just dividing it by 2. 1 divided by 2 is 0.5, 0.5 divided by 2 is that, right, and so on. So this is geometric. Right, so why it is the geometric? Because the common ratio r is equal to 3. The r is equal to half, right? And how do we get half? Is half divided by 1, quarter divided by half. We get r is equal to half. In other words, common ratio is half. What's the recursive formula? The recursive formula is an equals, right, a1 if n is equal to 1, and r an minus 1 if n is greater than 1. So that's equals to, what's a1? a1 is 1 if n is equal to 1, and r is half times an minus 1 if n is greater than 1. And then what's that's a recursive? The explicit formula is an equals a1 r to the power n minus 1. a1 is basically 1, so I'll just give that odd 1 times everything, right? r is half to the power n minus 1. So it's just half to the power n minus 1 half, right? What's a half word? Half to the power n minus 1. I hope you're listening to that. So that completes number 12. Number 13. We want to find the sum. We'll find the expansion of each series and then find its sum. So 13a, right? The sum formula is Sn equals a1 r to the power n minus 1 over r minus 1. Now, if you're looking at a, sigma sum k equals 1 to 5, 3 times 2 to the power n minus 1. Now remember, 1 to 5 basically means you need to substitute the values of n as 1, then move on to 2, then 3, then 4, then 5. So you got 5 minutes. So now we're doing this 3 times 2 to the power 1 minus 1 plus 3 times 2 to the power 2 minus 1 plus 3 times 2 to the power 3 minus 1 plus 3 times 2 to the power 4 minus 1 plus 3 times 2 to the power 5 minus 1. Now if you simplify all this, the expansion for each one, 1 minus 1 is 0, 2 to the power 0 is 1, so you got 3 as the first time. Put it on your calculator if you don't know how to work well. 2 to the power 2 minus 1 is 2, times 3 is 6. So you kind of like just doubling each one. 6 times 2 is, because times 2, r is 2, is 12, 12 times 2 is 24, and 24 times 2 is 48. If you check this, let's work out the last term and see if it's actually 48. 2 to the power 5 minus 1 is 4. So 2 to the power 4 is now give me 16. 16 times 3 is 48. So it is correct. Let's see what we can add up and how quickly we can add up on the sum. 48 and 24, that's 72. Plus 12 is 84. 90, 93. So the sum is 93. Because we have few terms, we can just add up the sum manually. Otherwise, we can find S5 from the formula above. S5 because there are 5 terms. A1 is just 3. The first term is 3. R is 2 to the power 5 minus 1 divided by 2 minus 1. 2 minus 1 I can just leave out. 2 to the power 5 is 32 minus 1, which is 31 times 3 is 93. So I get the same answer in both cases. So whichever one is preferable to you, use that. In this case, I'll just use the first method, just add it up manually because I have very few terms. Looking at the next problem, which is B, number 13b, we can see we got k equals 1 to 6 and 1. Because you know how to expand, I'm not going to use the expansion method, I just use the formula k minus 1. Right, so because you know how to expand, the first term you should get is 5. How? Because when I substitute k as 1, you get 3 to the power 0 and then, yeah. So now after 5, I'm just multiplying that thing because that's a common ratio. So 5 times 3. The next term I get is 15 times 3, 45, then times 3. 45 times 3 with 135 plus 135 times 3 with 45 times 3, 135, then times 3, we're getting 405, right? And then plus times 3, 405 times 3, 1215. Right, and if we add up all this, 1215 plus 405 plus 135 plus 45 plus 15 plus 5 is 20. We should get an answer of 1820. I hope you understand this. Next one, we just need to sum up 4 terms. So part C, summing up 4 terms of R equals 1 to 4. Remember, I just changed the variables here because it's just a counter. It can be x, k, r, p, anything. 4 times, this is 4 times half to the power r minus 1 I can see the first term is a, which is 4. The next term is dividing by 2 or multiplied by half. 4 times half is 2. And then dividing it by 2 you get a 1. And then dividing by 2 you get half. So if I add up everything, I will get 7.5 or 7.5. You can also write your answer as 15 over 2. I hope you understand, guys. Looking at the next question, we want to find how many terms are in the geometric series. So number 14a. To find the number of terms in the geometric series, you got 75 plus 300, because they're telling us it is geometric, right? 4915, 200. How many terms are in this geometric series? We are given the last term, so it gives the explicit formula. So we got an equals a1 or to the power n minus 1, which is equal to the last term, right? So the last term is 4915, 200. This a1 was 75. What's the common ratio? 300 divided by 75, which is 4, because it's geometry. That's 10 minus 1. Now we take 4915, 200 divided by 75. Let's see what we get. 4915, 200 divided by 75. So we get 65536. 65536, which is 4 to the power n minus 1. Now we want to solve for n minus 1, which we have done before, which is the log equation. So because you're solving for the exponent, we have, say, log 65536 base 4. I should get, I'm getting an answer of 8. But remember, n minus 1 is equal to 8, so n is equal to, there are 9 terms. Right? There are 9 terms in this geometric series. I hope you understand, guys. Don't forget to give comments in the comment section below. Next question, looking at 14b, part B, we got 20 plus 60, 20 plus 60 plus, I'm not writing all the terms, plus dot, because we already know it's geometric. 1180, 980, same problem, right? Something similar to what we have done before. Just the values of A1 ratio rather than us to be different. So AN equals, what's A1? A1 is 20. What's the common ratio? 60 divided by 20, which is 3, to the power n minus 1, which is equal to the last term, which is 1180980. Now if I take this and divide it by 20, this is what we get. 1180980 divided by 20. I'm getting an answer of 59049, which is 3 to the power n minus 1. Now I need to take log, so n minus 1 equals log, basically 59049. I'm getting an answer of 10. So n minus 1 equals 10, so we have 11 terms. Right? So we have 11 terms in this series. Next one, part C. $400, we have 100, we have 400 plus 100 plus plus 0.391, 0.391. So doing the same formula again, we have AN, which is equal to A1, which is 400. The common ratio is quarter to the power n minus 1 equals 0.391. So now we take 0.391 and divide it by 400. And I'm getting an answer of 9.775 times 10 to the power negative 4, or I'm getting 391 over 400,000. Right? That's quarter to the power n minus 1. And if I want to solve for n minus 1, so n minus 1 is equal to log of that base quarter. Log of 391,400,000 base quarter should be at n minus 1. Take to the nearest approximation, right? So log, I'm getting also 4.99993, so it is approximately 5. So n is equal to, we have 6 terms. I hope you understand, guys. Right, let's look at the next question. Question number 15. So question number 15 says the sum of a geometric series is 2, 3, 5, 1, 4, 6, 1. So the sum, so number 15, they're telling us that the sum is, so we know Sn, which is a1 r to the power n minus 1 over r minus 1. The sum is already 2, 3, 5, 1, 4, 6, 1, right? And the first term of the series is 7, that's right, because 7, a1 is 7, and the common ratio is 6, common ratio is 6, so 6 to the power n minus 1 over 6 minus 1 is equal to 2, 3, 5, 1, 4, 6, 1. So the first thing that we do is we need to multiply, remember this is 5. So we need to multiply by 5 and then divide it by 7. So see, we kind of like doing this. So 6 minus 1 is 5, right? So we multiply by 5 and then dividing it by 7. So we're going to multiply by 5, right? And divide by 7. So if we multiply by 5, this 5 and this 5 will cancel out, and that 7 and that 7 will cancel out. So we will only be left with 6 to the power n minus 1, which is equal to, so whatever you do on this side, do the same on the other side, right? Log, basic law of Gauss equation. So you're going to multiply by 5 over 7 and this side is log. So if I multiply that side by 5 over 7, I will get 2, 3, 5, 1, 4, 6, 1 multiplied by 5 over 7. Multiply by 5 divided by 7. We get 1, 6, 1, 6, 7, 9, 6, 1, 5. Now, we got this answer. We can't take log as yet because we got a minus 1 here. So you take the minus 1 over and add it. So you get 1, 6, 7, 9, 6, 1, 6, and that's 6 to the power n. Now I can solve for n by taking log of this base 6. So I'm taking log of 167, 9616 base 6. And I get an answer which is n is equal to, let's see, I'm getting n is equal to 8 direct. Right, remember there's no minus 1 on top, so there's no need to transfer anything over. So n is equal to 8. So how many terms are there in that series? How many terms are there in the series? There are 8 terms in the series. Moving on to question number 16 and solving these radical equations. Number 16a, we got x minus 5, right, plus 9 is equal to 13. Very simple equation. I can take the 9 over and solve, right? So we got 4 here, 13 minus 9, and the square root of x times 5. So how do you solve this equation? We can just square both sides, right? Because when you square a square root, it falls off, right? We're squaring both sides, so 4 squared is 16, and if we square this, we get x minus 5, right? And now we need to take the minus 5 over, so we get x is equal to 21. And let's check it down. So what's 21 minus 5 is 16, square root of 16 is 4, 4 plus 9 is 13. Looking at part B, question, right? Part B is cube root. Cube root of x minus 8 is equal to -3. Very simple to solve this equation. Because we have a cube root, we will cube both sides, right? So to the power 3, to the power 3. So this is a method. right? And if we cube both sides, this becomes x minus 8, whatever is on the inside. And negative 3 cubed is negative 27. And if I add the 8, I get negative 19 as my answer, because negative 27 plus 8 is negative 19. Remember to find extraneous solution, which is irrelevant solution. Maybe in part C we will find irrelevant solutions. Right, so now we are looking at part C, which is x is equal to square root of 8x plus 20. Again, because we have a square root, we will square both sides, right? Now squaring both sides gives us x squared here, on the other side gives us x plus 20. Bringing everything over, we got x squared minus 8x minus 20 is equal to 0. We can factor this out, we get x minus x, right? I think 10 and 2 will work, so minus 10 plus 2. So x is equal to negative 2 or x is equal to 10. Now we want to see which solution works. So if I substitute negative 2 inside here, obviously the square root of something can't be a negative number, so this one is extraneous. It is irrelevant, right? Extraneous is x equals negative 2 and x equals 10 is the actual solution. What does extraneous mean? It's kind of like rejecting your solution, or it is an irrelevant solution, the solution that does not work. Moving on to the next question, D. We have x plus 6 equals square root of x plus 6. Right. Now, if we want to solve this equation, very important identity is, when you square a binomial, which is a plus b all squared, we get a squared plus 2ab plus b squared. So we get 3 terms when we square a binomial. The reason why I've done this is because, when you're applying here, you don't end up with 2 terms, we get 3 terms. This is square root, that's why we are squaring. So that's this x plus 6, because we are squaring a square root. But on this side, we are squaring a binomial. So we get x squared. What's the middle term? Middle term is middle term is 2 times x times 6, so plus 12x, and plus 36. Bring everything over, you get x squared plus 11x plus 30 equals 0. Now we factorize this. X equals 0. I can see 6 and 5 working, so plus 6 plus 5, or you can use a calculator to solve. Mode 5, 3, put 1, 11, 30 ABC values, and you should get an answer of x equals negative 6 or x equals negative 5. Now we want to see which one is extraneous. So let me substitute negative 5 inside here, getting 1. Square root of 1 is 1, so that works. Substitute negative is 6 inside and getting 0, so both works. There is no extraneous solution, both solution works. Moving on to the next question, which is D. We have just done D. Let's look at E. Square root of x plus 7 minus square root of 8x equals negative 10. Now we have 2 surds. This way to solve this multiple surd equation is move the similar surd on the other side, which is the surd that has fewer number of terms, like 8x. This one has 2 terms inside the surd. So move that to the other side and square both sides. So we have x plus 7, which is equal to negative 1 plus square root of 8x. Now we're going to square both sides. If you square both sides, this side will end up with 3 terms. The other side, because you're just squaring up square root, so what you will get here is x plus 7. On this side, you will get 3 terms. Negative 1 squared is 1. The middle term is negative 2ab, right? So negative 2 square root of 8x. And if I square the square root of 8x, I'll just get positive 8x, because you're squaring a square root. A squared plus 2ab plus b squared. Remember that. Now we connect everything on the other side and solve. So bring the 8x over here, negative 7x. X minus 8x, then 7 minus 1 plus 6 is equal to negative 2 square root of 8x. Now we square both sides again because we have a square root. Right, so square here and square over here. Right? So I get 49x squared. If I multiply 2 times negative 7 times 6 is 42 times 2, so negative 84x 2ab plus 36 equals, if I square the negative 2 I get 4, if I square the 8x I'll just get 8x. If I square the square root of 8x I just get 8x. Now remember 4 times 8x is negative 32x. We get negative 32x on that side. Bring everything over. So you get 49x squared minus 116x out because minus 84 plus 32, that's positive negatives. Should be. Right, so negative 84x, negative 32x, negative 116x plus 36 equals 0. Now, because we have such large numbers, we will just use a calculator and mod 53. Mod 53. Output 49, output the negative 116 and 36. So I'm getting an answer of 2 and 18 over 42. Yes, I'm getting two answers, 2 and 18 over 49. So x equals 2 or x equals 18 over 49. Now because I'm getting 18 over 49, that should just be x minus 2, and the other factor should be 49x, right, because 49 times x, and then bring the 18 over, so minus 18 is equal to 0. What we will find is that x equals to 2 will work in the original, right, but x equals to 18 over 49, this one will be the extraneous. Because if you substitute 18 over 49 on this side, you will never get a negative 1 with this side on it, right? That will be an irrelevant solution. But x is equal to 2 is a solution because we can double check it. 2 plus 7 is 9, square root of 9 is 3, 8 times 2 is 16, square root of 16 is 4 is negative 1. X equals to 2 works because it's a solution, but the other one does not work. I hope you understand, guys. F. Quickly to solve f, same method as the previous one. So we have square root of 19 minus x minus square root of 10x is equal to negative 2. We move that over. So negative 2 plus root 10x is basically the same as the previous problem, but just different numbers, right? So what we're going to do is square both sides. As I explained before in the previous problem, we have done it in detail, so I'm just going to write down the solutions quickly. So we have 19 minus x because we are just squaring the square root, but over here we're squaring a binomial. So we got 4 minus 4 root 10x plus 10x, 2ab, middle term, and the last term b squared. Collecting everything over to the other side, 19 minus 4 is 15. Minus x minus 10, so minus 11x equals negative 4 root 10x. Now again we will square both sides, right? So 225, because we have a binomial here, 225, what's the middle term? 15 times 11 times 2, right? So 15 mod 15 times 11 times 2. I'm getting 330. What do we get? 15, 19, 15. Just double checking all this if they're done correctly. It's minus 7 on the other side. This area should be minus tool. Just copying the question into vectors. Hi guys, solving question number 17a, solve for y in terms of x. So we need to solve for y, but the answer can't contain x. So let us solve this. We have 2 times the cube root of 17, cube root of 12, plus y is equal to x. Now because we need to solve for y, the y is inside the cube root, so we need to get rid of all the other stuff. So if you take x divided by 2, divide both sides by 2, we will be left with 12 plus y, which is the cube root. Now because it's a cube root, we need to cube both sides. So if we cube both sides, we should get x cubed over 8 on this side, because 2 cubed is 8, x cubed is x cubed, and because we are cubing a cube, we just get 12 plus y. Now solving this equation, you can just take the 12 over and we got y is equal to x cubed divided by 8 minus 12. That basically means we solve for y in terms of x. The answer contains x. Part B. We have x is equal to square root 5y over 15. So the first thing what you can do is you can cross multiply. 1 times 5y is 5y square root, and 15 times x is 15x. Now in order to solve this, we can square both sides. Square here and square there. So if we square 5y, square root of 5y all squared, you get 5y. And if we square 15, you make 225 x squared. We need to solve for y, so we'll divide both sides by 5. So if I take 225 and divide by 5 using my calculator, I think you should get a 45, right? So let's see, 225 divided by 5, I'm getting 45x squared. Yes, and that's right hand side. 45x squared. Looking at the next question, solving each equation. So that equation is in the form of a rational exponent. Equations involving rational exponents. So number 18 here. We have x squared minus 2x minus 10 to the power 3 over 2. Minus 126 is equal to negative 1. So the first step is we will take the negative 126 on the other side. So we got x squared minus 2x minus 10 to the power 3 over 2 is equal to 125, because negative 1 plus 126. Now because we have to the power 3 over 2, we will raise it to the reciprocal power, to the power 2 over 3. So it cancels out. 3 times 2 is 6, 6 divided by 6 is 1. And same here to the power 2 over 3. But now we know 125 is 5 cubed to the power 2 over 3. You can see the 3 and the 3 cancel out. We get 5 squared, which is 25. So this side is 25, and that side is x squared minus 2x minus 10. If we bring the 25 over, get a nice neat quadratic. Minus 2x minus 35 is equal to 0. If we solve this quadratic, we get x minus 7, because 7 and 5 will work, x plus 5, or you can use mod 5, 3 on the calculator. So you get that x is equal to 7, or x is equal to negative 5. I hope you understand, guys. Let's check if this answer is correct. So these are the steps in solving this problem. Looking at the next one, something similar to this, part B. We have 0.8 x squared plus 2x plus 110 to the power 2 over 3 is equal to 20. Right, so the first thing we will do is we'll divide both sides by 0.8. So we get x squared plus 2x plus 110 to the power 2 over 3 is equal to 20 divided by 0.8. So we get 25. Right? And because it's to the power 2 over 3, we will raise both sides to the power 3 over 2. Right? And that's that to the power 3 over 2. But now we know 25 is 5 squared. So that's kind of like 5 squared to the power 3 over 2. And 3 over 2 times 2. Okay. So we know, or you can just say 25 to the power 3 over 2 on the calculator. So you should get 125 on that side. And this is just x squared plus 2x plus 110. So we're getting x squared plus 2x plus 110 minus 125 is negative 15 is equal to 0. If you solve, you should get x plus 5 into x minus 3, which is equal to 0. So x is equal to negative 5 or x is equal to 3. I hope you understand, guys, and you like my entire you went through every single problem, all these 18 problems. All the best for exams, and don't forget to like, subscribe to my YouTube channel, and also comment on in the comment section below. Thank you.